Hey, my name is Thomas and this is day 26 of 100 Days of Code in IoT Challenge. Today I'm gonna show you how to create and parse JSON documents with ArduinoJson library. And also we're gonna do a small summary of the recent videos on the subject of file system, HTTP, HTTPS communication and web servers. So let's move to the code. Right. Today we're gonna start from creating a new project. So Visual Studio Code, that is the IDE I'm using with PlatformIO. So I'm going to PlatformIO Quick Access, open, and then new project, project name. So today we're gonna be working with JSON, so maybe ESP JSON, that's how I'm gonna call it. The board node MCU, and the framework Arduino location, default location, finish. Great. Few seconds, and we should see the platformio.ini. Okay, the first steps are gonna be the same like in, I think all of those videos about file system and web servers and clients, everything like that, right? Today we're still gonna use file system, but this video is not really about file system if you think about this, right? Parsing JSON and creating JSON with ArduinoJson library. It's not really file system, but we're gonna need file system for HTTPSClient, for example. So yeah, but first things first, and that is gonna be monitor speed and board build.filesystem little fs. The reason we need file system is the fact that I'm gonna use HTTPSClient today as well, and it requires us to initialize the certificate store to validate SSL certificates of websites that is going to be connecting to. Right, so both build file system, then in the main.cpp in setup, I'm gonna do serial begin and baud rate the same I set for the monitor speed, delay to not miss any communication coming from the serial port of the device. We also need a data folder here. Then inside the lib, I'm going to clone my core library. So that's gonna be core. This command is going to be enclosed in the description of this video. So if you want to reflect my steps, you can just run it, you can find it there. However, after that, it is important to go to core and then to check out to day 25 to have exactly same state of the code that I'm working today, right? What is in day 25? What I've done yesterday, essentially, I have added let me show you, to the request, I have added possibility to stream the body. So we can upload files now using the binary way of uploading the files. The multi-part is still missing, but that's gonna be done in the future. Okay, so we've got the library, we've got everything to start except for the certificate store. And certificate store, I'm gonna need to go to data and then run docker. Again, for this entire example I'm working on today, for this to work, you need a certificate store. And to get certificate store, the easiest way is to run this docker command. However, that requires docker installed on your machine. And if it's not installed on your machine, in the description you can find the link to instructions. So I'm just gonna run it. Cool. And we should have this certs.ar in data now. Right, I've got that, but it's not on the flash memory of the device. And that's what I'm gonna do it right now. I'm gonna upload that file, this certs.ar, to device's flash memory. Make sure device is connected to the computer. And then this can be done from PlatformIO, project tasks, node MCU v2, platform, and upload file system image. It's gonna take a few seconds, and we should have this done. Cool. Yeah, this is done. Right. And now, finally, today's subject, which is the ArduinoJson library. I need to install it though. So again, PlatformIO quick access, this time open libraries and ArduinoJson. And this is gonna be that one, ArduinoJson. You need to click on it and then add to the project. And you need to select that the project that you, that's gonna be ESP.json in my case. And add, and that's it. The library is installed and added to my project. Right, so I can actually include it now. Include ArduinoJson. To really show you this library in action, what I could do today is to summarize the most recent videos on HTTP and file system, right? The bit on the file system really, the file system upload, video 21, I have just done with PlatformIO. What else we did was the web server. So that's gonna be another thing I'm gonna do today. I remember there was video 22 and video 23. Recommend watching it if you haven't watched. And video 24, which was HTTPSClient. So I'm gonna connect HTTP server with HTTP client. We're gonna host HTTP server on the local network. And one of the endpoints is going to call HTTPS endpoint that responds with JSON. Is going to pass the JSON, do something, and respond. So we will see that JSON modified, right? But yeah, let's just start writing the code then. Okay, so to not repeat myself on these things, like initializing HTTPS client and HTTP server, I have prepared some code already here. So let me just copy paste it. So I'm just gonna paste it in. We've got ArduinoJson, cert store, web server, Wi-Fi multi-event dispatcher, HTTPS client, little fs, timer, and Wi-Fi manager. Then what we need is to define SSID, so the local Wi-Fi network name and password. Initialize web server. And also create the instances for the certificate store, for timer, event dispatcher, Wi-Fi multi. These are required for Wi-Fi manager, and Wi-Fi manager is required for HTTPS client, as well as cert store and timer. So this is for creating all the instances that we're gonna use today. Then I need to initialize certificate store. I've also done that. Video 24 and yesterday's video. So I'm not gonna do it again. I'm just gonna copy paste from yesterday's example. Right, so we're initializing file system here and initializing the certificate store that essentially reads the file that I've just uploaded with the file system image upload. And I think this is gonna be it. Oh, okay. For the loop, I need to run timer tick. And also, what I would like to do to speed this up is to pass the Wi-Fi manager connect. And only if the status is connected, we would like our server to begin, and we would like to set this callback on loop, which is gonna just continue handling all the connections coming to the web server. And I think this is pretty much it from the web server point of view, like for the initial setup. And now I'm not gonna be copy pasting anymore. Right, so we have the server initialized, and for the server I'm going to add endpoints. So one endpoint is gonna be just the base one, and that base endpoint is gonna make use of ArduinoJson. But let me show you the documentation first. In my opinion, this is one of the nicest libraries created for Arduino / ESP8266, ESP32, and many other boards. Actually, it supports many other microcontrollers. Really well documented, and very efficient, fast, and doesn't consume lot of memory. However, yeah, that mainly really depends on the size of the website, the size of the payload that you're trying to pull or to work with. Okay. Right. Two main things on this, on creating a JSON documents with this library, is the memory allocation. So there are two ways. One is the static JSON document. This is put on stack, and dynamic JSON document that is put on heap. They have like some sort of allocation strategy for the dynamic JSON documents. However, on microcontrollers, the recommended way is static JSON document, and that ideally would be put as a global variable, so you have just this one single container for the JSON document. But really, this depends on the case, because I still can imagine cases where you want to do this as a dynamic JSON document or something, right? So I'm actually gonna copy this line and paste it in somewhere here as a global variable. So this is gonna be our JSON document container. I'm gonna allocate more memory, like 2 kilobytes. And now for the endpoints I have just created here, I would like to respond with some JSON, right? To respond with JSON, like normally the way I used to do it was just server sent and then 200 application /JSON, and then for the content, to really respond with JSON, you can just do something like that, right? So message, something like this, right? Okay. So, I'd suggest if your response is just as simple as that, I wouldn't use ArduinoJson, right? However, if you have something more complicated, so imagine maybe a response from the sensor that includes, let me show you. So let's think about something like that. So we have something like sensor DHT11, and then temperature, and temperature is another object, and then we have value like 20, and then unit, which is C, right? Then we have something like day, I don't know, true, just an example, JSON, but you know, the point is it is more complex, right? You know, what we could also have is coordinates. Coordinates. This is just to demonstrate an array where you have like something like that maybe. Okay. And that could even go on, like this could be nested like further, right? So we could have like something like that and then go on, and then we could go on and on, right? So for this sort of documents, working with strings or C strings would be very problematic. And this is the case where the ArduinoJSON comes useful, because for that, what we could do is to take our document and set all of those values in the key value way, right? Like working with maps. So we can do something like sensor equals DHT11, and then we have temperature, and that temperature is has a value that is 20, and it has unit, and this is C, and then we have something like day, true, and we have coordinates, and that coordinates is it's a different type, it's just a collection, an array, and we can have something like that, right? And let me just copy paste that and change this to 1 and have something like maybe something like that. Okay, right? So this is way simpler, and you know, imagine you actually obtain this data from many different sources, use different functions, and having this, you know, done as a sprintf, for example, would be too problematic. So this is where ArduinoJSON comes handy, right? And then what you are supposed to do is you still need to have the char array ideally. So that's what I do usually. I have something like a body, and that has the same size as the JSON document, and then we have serialize JSON, and that takes source, which is the document, and destination is our body. It is going to write to, and then I can pass the body here. So my web server is going to respond with that. Okay, so let me show you this in action. But before I do that, I've just realized I won't be able to find out about the host address to my web server. So let me just quickly paste this line. Okay, and I'm quickly gonna go through the code for those who are not familiar with my code yet, with my libraries. So let me explain it here. Okay, so we're gonna start from this point, from the Wi-Fi manager. The way Wi-Fi manager works is you are supposed to call connect, and you pass the callback. So it is like connecting to Wi-Fi, but in a non-blocking way, right? This is gonna be called eventually. It might be connected, might be not connected. There is a timeout of 5 seconds, can be changed to higher value or lower value. But essentially the point here is to give the device 5 seconds to connect to Wi-Fi, and then call this callback with the result. right? And if the result is connected, then we start the web server, we put handle client on loop. What does it mean? That means that as a part of timer tick, this handle client is gonna be called. This is required from ESP8266 web server to handle the clients, right? Because there might be incoming connections all the time. So it needs to like listening on and on the loop. So that's what happens here. Then I simply print out the information about the host on my local network, where the server is going to be serve all those endpoints, right? I'm gonna show you in a second. I will get this information in my serial monitor, and I will be able to just click on it, and that's gonna open the page for me in my browser. So this is on the Wi-Fi manager. Timer is really to handle this non-blocking approach. We also have things like event dispatcher. We're not really using it today, but it's used by Wi-Fi manager. This is to handle events when the Wi-Fi is connected or disconnected. And Wi-Fi multi is just a built-in object that we are supposed to pass to Wi-Fi manager to establish the connection. And certificate store is to handle SSL certificate verification. The reason for that is actually gonna be, this is gonna be the code I write in a second. So let me show you this example. I'm gonna deploy, and then I'm gonna explain, okay, something missing. What is missing here? Let me check. So void loop, timer tick. Oh, I see, okay. Is that correct? No. Okay. So yeah, it was just a closing brace. Anything else? Oh, I see. Okay, let me go to HTTPSClient. It doesn't like my HTTP method. It doesn't like because it clashes with ESP. It clashes with this one, with the one from the web server. So I really need to modify it quickly. You know what we're gonna do? I'm gonna put this enum as a part of the request. So we'll have request HTTP method. And because I don't really use it right now, that should just work. No, doesn't. Oh, really? Yeah, it doesn't, because I'm gonna have to modify it here now. So that's gonna be request HTTP method, and wherever the HTTP method is used, 6 places, I'm gonna have to add the request bit here. Okay, so now this is working, so I'm gonna deploy the code. Okay, deployed, serial monitor connected, and we have an exception. Let me investigate it. Right, I've investigated it, and it turns out that has to be swapped. For some reason, once you start the server, it doesn't like the handle client to be called right after in the next timer tick, in the next tick. For some reason, something for me to figure out myself. to debug this, whether it's the fault of the timer, something I missed on the timer, a mistake I've done, or it's just something on the server itself. But anyway, let me deploy it now. It should be fine. Connected, and there we go. So we've got the link here. I'm just gonna have to follow it. So I'm gonna open it in the browser and let me show you how does this look like. Right? So that's what we get. The sensor DHT11, temperature, value unit, day true, and coordinates. So that endpoint here works really well. It works really well. And now let's just quickly create another endpoint. This time this is gonna work with HTTPSClient. So I'm gonna call it maybe users or user. I tell you the reason why I called it user in a second. Okay, so I was thinking about using some REST API. I couldn't really find anything. And then I found another website, which is this just placeholder, JSON placeholder. And I'm thinking about using the users endpoint, but not this one, not the whole thing, just users/1. Because using everything, this is probably too much for ESP8266, too much for its RAM memory. And working with streams at this point with the ArduinoJSon, that would take too much time. So we're just gonna go for the simple example. Users/1 is gonna be the endpoint that I'm gonna call using HTTPSClient from ESP8266. Then we're gonna remove address, and I will change username to something else, and that's gonna be what I send back to the browser at the user endpoint. Okay, at the moment it's not implemented, but let me implement that with HTTPSClient. Cool. So we've got user here, and yeah, what I need to do is just call HTTPSClient.send request. That requires request. So we're gonna use the builder. We need to pass request method, and this is gonna be get, and URL is the URL I need to copy paste. So it's this one for the example API. I'm gonna paste it, and then we don't really have any body or headers. So this is it. We just need to pass a callback that is going to be called once this request is done. And then we need to handle this accordingly. So if there was an error, what we want to do is to respond with error. We want to respond with error, and for that, what I'm just gonna do is to do server.send 500, then content type application JSON. And here what we could do is to use our JSON document. Let me check if I can clear this. Okay, so that's how you clear it. And then I'm just gonna put something like error and res error. And then I'm gonna do serialize JSON. Source is gonna be the document, and body is gonna be the target. And I'm gonna just pass the body here. Right. I can actually clear the document here, because in case that was successful, what you would like to do is to read the body, deserialize it to JSON document, modify it, and serialize it back. That's what I'm gonna do. So let me just quickly do it. So deserialize JSON. That requires us to pass a document, And the second argument is gonna be the body. I'm gonna use the read string, that's the pointer, so it has to be done like that. Read string. That should deserialize it into a document. And what I was thinking about doing is, again, remove address. So now I can just manipulate, do some data manipulation on this document, like remove method, for example, is gonna remove the address, and then let's say I would like to modify username, and let's call it new user, something like that. And then we're gonna do serialize from the document to body, and I'm just gonna send 200 application/JSON and that body. So we're using HTTPClient here. Let me just quickly go through it again. Right, so I'm using HTTPSClient send request method that underneath actually makes sure we are connected to Wi-Fi. It makes sure the clock is synchronized for the SSL certificate verification, right? We use HTTPS here. And then it makes the request using HTTPSClient. It makes request to this resource, right? It's this one, just an example, endpoint. And once everything is done, it just runs this callback and passes the response. Then what do? We clear the document, the JSON document, because we're gonna be writing to this document. If there was an error on the response, then the error member of this struct is not a null pointer, and in that case we create a property error on the JSON document. We serialize that JSON into a body, and we respond with that body status 500. That's it for that callback. However, if there was no error, we deserialize the JSON into a document. So we read the body as a string, and that's gonna create a JSON document out of this string body. Then we do some manipulation. We remove the address property on the JSON. We set the username to new user. You know what? I can actually add something extra to this document, and then we serialize it into a body char array, and we respond with status 200, and that body serialized, right? So we should see this in the browser in a second. So let me deploy that now. Okay, so that's deployed. And you know what I'm gonna do? So we close this section here. Can I do this? Close this section here so we can see what's happening in the serial monitor. And now I'm gonna go to this user. So waiting for NTP timesync. This page is not working. We got the empty response. This is probably due to the fact that the time synchronization stops the ESP8266 web server and makes it sending an empty response. Let's wait for the clock synchronization, and I'm gonna try again. And then I'm gonna show you how to fix it. Okay, so yeah, now this has happened. We won't see anything here. Oh yeah, there's more requests. Probably browser tried to do it more times. Okay, so I'm gonna reload now and see what happens. We should get the response now in a JSON format. Let's just give it a few seconds. There we go, right? So we've got this user from here, but without address. right? There was an address here, no address here. And we have username, new user, and extra, 1, 2, 3. Exactly like I said on the JSON object. Okay, let me just quickly fix that issue and we're gonna be good for today. So I'm going to go back to IDE. Right, so for this one, I'm gonna have to extract the timer, the clock synchronization from the HTTPSClient. I was planning to do it anyway, so I'm just gonna do it now because the fact, you know, the process of synchronization for the first time breaks the connection. And what I'm gonna do is, first of all, I'm gonna create a new file here, setclock.hpp. And this is gonna use timer. And then in the HTTPSClient, I'm gonna move entire method and turn it into a function. So gonna move it from here to here. We need to take a timer as well, a pointer to the timer, because this is not an object anymore, this is not a class. So we've got that, and here we still need to synchronize that clock. So what I can do, maybe as a first step, because ideally you could set the clock function on a constructor, but because I don't want to spend too much time again today, let's leave it for the refactoring session. I'm gonna use setClock straight away here and just pass a timer, this timer, because we have a pointer to the timer on this class. So that's what I'm gonna do. And however, the include is missing, so let me just include that set clock. So having that done and set clock HPP extracted, I can now include it here. Set clock. And then we're gonna do that synchronization here. So 1 second. If the status is not connected, we're gonna turn this around. So if it's not connected, then we're just gonna stop, return. Maybe I print something out as well. Something like could not connect to Wi-Fi. And then otherwise, we're just gonna do set clock, pass the pointer to timer, and then the callback. Here is gonna be the server begin. So once time is synchronized, we're gonna run this. We're gonna initialize the server, print this information about the host the server is listening on, and put the handle client on loop. Let me check if I haven't done any mistakes. Okay, that's correct. Everything's correct. I'm gonna deploy now. And we test it in the browser. Okay, that's ready. Connected to the serial monitor. And yeah, now we're waiting for the NTP timesync. So it is not gonna start the server until the NTP timesync is done. I can even show you maybe with the curl. Can I do it though? I need to minimize this again. So 1 second, let me just do, okay, yeah, it's synchronized now. So let's make a test now with the user. Maybe before user, I go here, right? So that still works. And now we go to user/user, and we should, after a few seconds, we should get the response here. And there we go, right? So, you know, now it didn't stop the connection. So now it didn't close the connection, right? Like before. Yeah, I don't know the exact reason why this is happening, but it's probably due to the fact that the clock is synchronizing. Something internally happens that drops the connection. Okay. So yeah, I really recommend looking at this library, link in the description of the video, and looking at those different tutorials. This is like super convenient library to work with. Maybe before I finish, I'm gonna show you one more thing that can be done with this library. So let's think about the case where you would like to, let's say you have we're gonna use the client here, right? So we're getting the user, right? And we would like to read some field, one particular field. Let's say this is ID, and we would like to check if that ID has the type we expect it to be, right? Because C++ is strongly typed, and we may not know what the type of the incoming JSON document, especially from the external resource, is going to be. And for that, what can be done is this is method that you can do on the document. You pass a generic parameter of the type you would like to verify, right? And here, sorry, it should be here. And here I'm just gonna try to access the field that I would like to check the type of, right? So what this is gonna do is to return false or true depending whether the ID can be cast to int or not, right? In this case, I'm pretty sure it can be, so we can even do something like that, ID equals and dog ID then, right? It's gonna cast everything for us automatically, and I can just do serial println ID. Another interesting method is, let's try to use something non-existing field, and I'm gonna use is null. This is again returning boolean depending whether the field exists or not, right? And if it's null, let's just print something out like is null, right? Non-existing existing is null. Okay, so one last deploy connected to the serial monitor, waiting for the NTP time sync. And yeah, in the meantime, I'm just going to prepare everything for test. Okay, listening. Server is listening, so let me just try. And there we go, right? So the response is the same, but we got these 2 extra bits, right? So non-existing is null because it doesn't exist, and 1 was the value that I extracted from ID. Okay. This was the last video on this file system /HTTP/JSON mini series. From tomorrow, I'm gonna go back to hardware. So again, working with sensors, and there is one project I'm thinking about doing, but I'm not gonna tell you today. And this is it for today. Thanks for watching. If you find this content useful and you would like to stay up to date with my channel, I suggest hitting the subscribe button so you will get notified as soon as I upload the next video. Thanks, bye!